Monolith versus microservices. When and how to evolve. Hello, everyone. Today I'd like to walk through monolith versus microservices in system design. This is one of the most common architecture discussions. But here's the mistake most people make. They treat it as a binary choice. In reality, it is an evolution strategy over time. When I think about monolith versus microservices, I usually break it down into 4 aspects. First, what each architecture actually means. Second, when to evolve, not just what to choose. Third, trade-offs like complexity versus scalability. And finally, safe migration strategies. Monolith versus microservices fundamentals. Let's start with the monolith. A monolith is a single deployable system with a shared codebase and often a shared database. This gives us simplicity, easier debugging, and strong consistency. But as the system grows, tight coupling increases, scaling becomes difficult, and development slows down. The key idea is monolith optimizes for simplicity, especially in early stages. Now let's look at microservices. Microservices split the system into independent services, each owning its own data and logic. This provides independent scaling, team autonomy, and fault isolation. But it also introduces distributed system complexity, network latency, and data consistency challenges. The key idea is microservices optimize for scalability and organizational growth. And here's the most important insight. Microservices are not about splitting code. They are about splitting ownership and scaling boundaries. When to evolve? Let's start with a common mistake. Starting with microservices too early. In early stages, the complexity is not justified. So when should we split? Signal 1 is scaling bottlenecks, where a single component dominates resources. Signal 2 is team bottlenecks, where teams block each other in a shared codebase. Signal 3 is deployment friction, where releases become slow and risky. Signal 4 is clear domain boundaries, where business domains are well understood. The key idea is do not split by technology, split by business domain. Trade-offs and costs complexity. Monolith is simple. Microservices introduce distributed complexity. Data consistency. Monolith provides strong consistency. Microservices often rely on eventual consistency. Latency. Microservices introduce network overhead. Operational overhead includes deployment, monitoring, and debugging complexity. The key idea is microservices trade simplicity for scalability and flexibility. Evolution strategy. Step 1 is a modular monolith with clear internal boundaries. Step 2 is extracting high-value services where scaling needs differ or boundaries are clear. Step 3 is API-first design with stable contracts before splitting. Step 4 is defining clear data ownership per service. Step 5 is gradual migration using the strangler pattern. Step 6 is adding observability and resilience through tracing, retrees, and circuit breakers. The key idea is microservices are adopted gradually, not all at once. Summary to summarize. Monolith is simple and strongly consistent. Microservices are scalable, flexible, but complex. Closing insight to conclude. The biggest mistake is treating microservices as a starting point. They are actually an optimization for scale and organization. Great systems do not start with microservices. They evolve into them when the system and team are ready. Thank you.